This video is over section 1.5, Linear and Compound Inequalities. A linear inequality is any relationship of the form ax plus b less than 0, ax plus b greater than 0, ax plus b less than or equal to 0, ax plus b greater than or equal to 0, ax plus b not equal to 0. And a and b are real numbers. A compound inequality is the same thing as a linear equality, but the statements have two or more inequalities. So they are statements with two or more inequalities, hence them being compound. All right, this first section says solve the following inequalities and then graph the solution set and write the solution set in set builder and interval notation. All right, for this first one, we are going to subtract 4 on both sides. And we've got negative 3x is less than 21. We're going to divide by negative 3. And whenever we multiply or divide by negatives with inequalities, this causes the inequality to flip directions. So this is going to turn into greater than negative 7. And so when we graph this on a number line, because it is just a greater than and there's no or equal to, we're going to graph that with an open circle. And the numbers are greater than negative 7 to the right. So we would shade to the right. For set notation, it's simply going to be x such that x is greater than negative 7. I'm going to write that here in a different color just so we remember what that means. This symbol right here is called such that. And in interval notation, this would be any number greater than negative 7. So here we're going to have negative 7 comma infinity. And we are going to put curved brackets around these because we cannot ever equal negative 7 because of the greater than symbol, and we can never put a physical dot on infinity either. All right, for this middle one, we need to simplify first, so we're going to distribute this negative. So we have negative 3x minus 3 plus 3 is greater than 4 plus distribute 3x minus 3. Combine some like terms, we've got 3x here, these go to 0, is greater than 3x plus 1. Subtract 3x on both sides, and we've got negative 6x is greater than 1. Divide by negative 6, and again, when we divide by a negative, that flips our inequality, so now we have less than negative 1/6. When we graph this on a number line, because it is a less than, we will have an open dot, and the numbers are less than to the left. In set notation, we will have x such that x is less than negative 1/6. And in interval notation, the smallest number less than negative 1/6 would be negative infinity, comma goes up to negative 1/6, but we do not include it, so it is another curved parentheses. The last problem in this section, we have some fractions, and so we want to consider the least common multiple of the denominators. So 2, 4, and 6, the least common multiple for those would be 12. So I'm going to multiply everything on the left side by 12 and everything on the right side by 12. And so for the first one, we're going to have 12 over 2 times x minus 1 minus 12 over 4 times 2x plus 1. We did not multiply or divide by a negative, so we can keep it less than or equal to. And then on the right, we're going to have negative 12 over 6x. Let's reduce all of our fractions. So this would be 6 times x minus 1 minus 3 times 2x plus 1 is less than or equal to negative 2x. We're going to distribute. So we have 6x minus 6 minus 6x minus 3 is less than or equal to negative 2x. We're going to combine like terms, and notice here 6x minus 6x goes to 0, so we're left with negative 9 is less than or equal to negative 2x. We're going to divide by negative 2. Because we divided by a negative, that flips our inequality, and 9 over 2 is greater than or equal to x, or you could do 4.5. However, when we graph this, we're going to put our dot on 9 over 2. It is going to be a filled-in dot because we have the or equal to. And then the variable is on the right side, so we will shade the opposite direction of this arrow. Or you can rewrite it before we do that, which we probably should anyway. If I flip to put the x on the left side, we want to make sure that because the arrow is pointing towards the x, it stays towards the x, even if you rewrite it the other way. So now that we've rewritten it, we can see that x is less than or equal to 9 over 2, so we are shading to the left. In set notation, this would be x such that x is less than or equal to 9 over 2. In interval notation, the smallest variable less than or equal to 9 over 2, number less than or equal to 9 over 2 would be negative infinity. The largest would be 9 over 2, and because it's or equal to, we will include it, but using a square bracket. The next one says solve the following compound inequalities. So there's two inequalities that we have to satisfy. So for the first one, we're going to add 4 to both sides. And x is greater than or equal to 10. On this one, we're going to multiply both sides by 3 because 1/3 minus 3 is 1. And we're left with x is less than 9. So when we try to graph this, because of the or, we are not looking for an overlap, we're just looking for two separate things. We have a 10 here and a 9 here. The 10 is greater than or equal to, so we're going to have a filled in parentheses here. Greater than or equal to 10 would be to the right. And it says or x is less than 9, open dot, less than 9 would be to the left. It doesn't ask, but we can go ahead and do set notation. So we're going to have x such that x is greater than or equal to 10, and just write or x is less than 9. That's perfectly fine. And then in interval notation, it's a little weird, so we're going to have negative infinity all the way to 9 not included. And then or would be this U symbol. It's called union. And it's just like a mathematical or. We're going to include 10, so we're doing a square bracket all the way to infinity. The next problem here, we have negative 2x minus 2 is greater than 3. So if we solve this one first, we're going to add 2. Negative 2x is greater than 5. Divide by negative 2, and we get x is less than, because of the negative, negative 5 over 2, or 2.5. This time we have an and. I'm going to multiply by negative 3 on both sides. So we have x greater than or equal to negative 12. So on our number line, negative 12 is over here, and negative 5 over 2 would be up here. And means they both have to be true. So if we start at negative 12, we have a filled in circle, and greater than will be this way. And for x less than 5 over 2, open circle, shading this way. So luckily they're pointing towards each other and they will both be true. So the solution set would be in the center. So to write that as a set, we're going to have x such that negative 12 is less than or equal to x, which is less than negative 5, to write those together. And then as a set notation, square bracket to include negative 12, comma, negative 5 over 2 with a curved bracket to not include that. Next it says solve the following three-part compound inequalities. So all that means is that it's already set up in 3 parts. So the first thing we need to do is get rid of the 2. So I'm going to multiply by 2. And when I do that, I have to do that all 3 places. Here the 2's cancel to 1. On the left, we've got 10 less than t minus 4 less than or equal to 50. Next, we need to add 4, and we have to do that all 3 places. So we've got 14 is less than t is less than or equal to 54. So as set notation, we would have t such that 14 is less than t, which is less than or equal to 54. And set notation, I might have said that backwards. That first one is, interval notation. I probably am saying that all backwards. Is 14 excluded, comma 25 included. Both answers are perfectly fine. And I'm not going to graph it. I think we understand. All right, the next one, we're going to subtract 4 on both sides. And we're going to have -1 is less than or equal to -x less than 2. We need to get rid of this negative, so we're going to divide by -1. And when we divide by -1, that flips our inequalities. So we do have x in the middle, but now we have greater than signs with a 1 here and a -1 here. And just to make it look cohesive with what we're doing and probably how the computer is going to prompt you to do it, we're going to keep x in the middle, flip our inequalities to less thans. Basically, we're taking this one here and this one here. And so we'll have a -1 here and a +1 here. So for set notation, we've got x such that -1 is less than x is less than or equal to +1. And interval notation, -1 is not included, so curved bracket, comma 1 included, square bracket. All right, the last one says Jessie has test scores 94, 90, 95, 94, and 94. Her scores for online homework is 87 and is weighted as 1 test grade. I'm going to underline that. Jessie still needs to take the final exam, which counts as 2 test grades. What score does she need on the final exam to have an average of at least 90? Okay, so to find her average, we're going to have 94 plus 90 plus 95 plus 94 plus 94, and her homework does count as 1 grade, so plus 87. Plus, if we make F the final, it counts twice, so we're going to do 2F divided by. Now here we've got 1, 2, 3, 4, 5, 6, 7 test grades. And so we are going to divide by 7. And we want this to be, actually we're going to divide by 8 because of the 2F. We want this to be at least, so greater than or equal to 90. So if we solve this equation, I'm going to go ahead and add those numbers up. 94 plus 90 plus 95 plus 94, 87. So we've got 554 plus 2F is greater than or equal to, and I'm going to go ahead and multiply 90 by 8, and I got 720. Subtract 554, and we have 2F is greater than or equal to 166. If I divide that by 2, we need our final to be greater than or equal to 83. And we will get a score of greater than 90. Yes, let me write that down. Need final exam score to be at least 83%.